Hi everyone, I am Boshara Praveen from Emertxe College of Engineering Technology. Today I will be presenting my project titled IoT-Based Home Automation Solution, developing during my internship at Emertxe Information Technologies. This project demonstrated how Internet of Things or IoT can be used to create a smart home that is energy efficient, secure and convenient. So let's do a quick about the introduction. The main idea behind this project is to use IoT to connect and control home appliances remotely. It allows everyday devices like lights, fans, and sensors to communicate through the internet. In these systems, we design a simulated smart home and that automates lights, temperature control, and water management. We use virtual sensors and actuators that are connected to the Blynk app, which acts as a remote control interface. The goal was to demonstrate a low-cost, practical home automation system that can later be implemented using real hardware. The required software for this project, several tools were used like Arduino for the writing and uploading microcontroller code, PicsimLab to simulate the microcontrollers and sensors, virtual serial port tools for serial communication between devices, and the Blynk mobile app to provide the graphical user interface for monitoring and controlling the system remotely. Together, these tools replicate how a real IoT setup would function. We can see the Arduino and virtual serial port interfaces now. Then, and in the demonstration, I will show the PicsimLab and the Blynk application interface. This is the Arduino IDE interface. We are already done the coding part for all the things. This is the main file and remaining all the header files and .cpp files of LDR and serial tank and temperature sensor. We are using the Arduino Uno as a board and Combine as a port. Select two things and just verify. We get the output has no errors. And export as a compiled binary, then we get the hex file. It is done. This is the virtual serial port interface. In that we can create ports as create local bridge, then select the ports and create. And we are using the non-permanent device, which needs subscription. So the ports are connected. Coming to the next slide. Next assumptions and dependencies. This project is entirely simulated. All sensors and actuators are virtual, meaning there is no physical devices connected. PicsimLab handles the microcontroller simulation, while the Blynk app handles the communication and visualization. The system depends on internet connectivity and accurate sensor emulation to mirror real-time data. The setup makes the project cost-effective and ideal for the academic learning. Constraints. Because the project runs in a simulated environment, mechanical and electrical factors like wiring delay, power loss, or signal noise are not considered. Also, cloud communication and data timing are simulated, meaning we assume near perfect response times. In real-world scenarios, these constraints would be need to tested and optimized. Functional requirements. The system performs four main functions. Collecting sensor data, such as light, temperature, and water levels, process this data logically in the microcontroller, send output commands to the virtual actuators like LEDs, coolers, and valves, and provide real-time control and feedback to the user through the Blynk application. This shows the full of IoT loop, sensoring and processing, acting, and communicating. Let's start with the garden lighting control. This part automates outdoor lighting using an LDR sensor. When the sunlight intensity drops below at a set level, the light automatically turn on and the switch off when the brightness returns. It's a simple but powerful demonstration of energy efficient automation. reducing unnecessary power consumption. So, temperature control system. The system uses an LM35 temperature sensor to monitor room temperature. The reading are sent continuously to the microcontroller, which decides when the device to turn on the heater or cooler and off states, and a heating resistor simulates the heater and a small DC fan represents the cooler. This helps to maintain a comfortable indoor temperature automatically. So we can control the cooler and heater switches. So both the cooler and heaters can also be controlled manually using the Blynk app. In the app, the user can switch devices on or off states. So overriding automate operation is desired. It gives flexibility automation when needed and manual control when necessary. So threshold temperature control. So this will help to if the 35 degrees is set. So when the temperature rises to 35 degrees more than when the sensor detects a valve above this, the cooler automatically active. The user also receives a notification on the Blynk app, ensuring awareness of system operation. This will help mainly safety and comfort efficiently. So if the temperature is more than 35 degrees and it is automatically off the heater, and we can switch on the cooler and it's gradually decrease the temperature. So next we can go to the water tank system. Then the next module monitors and manages the water tank level. A virtual sensor sends the water level data to the microcontroller, which it is then displayed on a character CLCD. This ensures user can always check the tank level in real time, even remotely. So inlet and outlet valve control. So inlet and outlet valves are operated through the buttons in the Blynk app. These buttons send serial commands to the controller to open or close the valves. The logic prevents both valves from being open at the same time, ensuring safety and preventing overflow or wastage. So volume-based water tank automation. So when the tank volume drops below the 2000, the inlet valve opens automatically to refill it. The user receives alerts through the Blynk app and see the updates on this LCD display. This ensure efficient water management, saving both time and resources. When the water tank is full, and it's also sent the notification, and we can switch, and it is also automatically off the water inlet valve. So Blynk app user interface. So the Blynk interface is designed with interactive widgets, buttons, gauges, and terminals. Temperatures and water levels are displayed in real time using gauges, while, button, while buttons control lights, fans, and valves. The terminal shows live system status, make the system intuitive and easy to use. So system workflow and project implementation. So the workflow follows five-step sensor capture data, microcontroller processing logic, actuators perform actions, data and actions are displayed in the Blynk, and the user can interact manually if needed. This loop demonstrates the complete IoT process from sensing it to cloud communication. So let's see the project demonstration. So this is the PicsimLab interface. So I already done all the required things of spare parts, serial remote tank, and the Blynk app interface of my mobile, and I load the hex file again. So it takes few seconds to run. So we can see in CLCD screen, it's showing the home automation. So it is started. So wait, it's showing something. So here we can see the temperature reading and also the volume level. So I already fixed all the things. So again, I will start with the garden light. So it is the LDR sensor. So LDR means light dependent resistor. So it is useful to resist the flow of voltage to the LED. So if the light intensity is more, so the LED is automatically off. So if the light intensity is less, so the LED is turned on. So we can show that the light intensity is more, the LED is off state. So if the light intensity is low, then the LED is on. So this is used to save the energy. So we can go to the next thing, heater and cooler switches. So here I can start with the heater switch. So if in the mobile app, Blynk mobile app, so I am on the heater switch. So if the heater switch is on, the temperature is gradually increases. So here he is showing the heater is on state. We can see the temperature is gradually increasing. So you see, we can see in the display and also the temperature gauge. The temperature is gradually increasing. So wait for a few seconds. So it's showing some slowly delaying. So we can see that if the temperature is more than 35 degrees, the heater is automatically off. You can see in the screen, and here also the heater will automatically off. So this is the advantage. If the temperature is rises more than 35, it is automatically off the heater switch. So then the temperature is slowly decreasing. So if we on the cooler switch, so I'm on the cooler switch. So we can it displays here. So we can see that the cooler is on state. So the temperature is gradually decreasing of like 1 degrees. If we switch off the cooler, it is the temperature is slowly decreasing. See the difference between cooler. So I off some time of cooler. So again we can this is the temperature sensor and we already connect all the required things. So next go with the serial remote tank. So I already connected the serial port as COM to. It is already filled. So I can on the outlet valve. So the water drains quickly and it is also shown the outlet flow is on. So here if the volume of the tank is below 2000 then the inlet valve is automatically on. So here we can see the inlet flow is on state. So it's showing some delay. So the water is filling. We can see the outlet flow is off state. So if the volume of the tank is filled fully, I mean 3000, then the inlet valve is automatically off. We can see it's showing some delays. So we can see the inlet valve is in off state. Yes, it is in off state. We can also see the volume of the tank here. So this is the Blynk app integration. We can control from the Blynk app with the authentication ID, authentication token, and some ID and names. And also we are using the PicsimLab for the simulation, and we select the board as Arduino Uno. And here we can add the sensor and CLCDs and temperature, and we are using the Ethernet port. So this is the Ethernet W5500. So we can also use as ESP32, but we are not using. So it is also same working like that. So this is the project demonstration. Thank you. So next, go to the next slide. So implementing challenges. During implementation, the main challenges were synchronizing simulated sensor data with Blynk, managing API delaying during the multiple operations, and achieving accurate sensor behavior in simulation. These were solved by the optimizing code using data averaging and scheduling update functions for the smoother performance. So key results in the future scope. So the project is successfully demonstrated a fully functional IoT-based home automation system in simulation. It is validated concepts like automation, feedback, and crowd control. For the future, real hardware can be added using the ESP32 microcontrollers, along with AI-based adaptive control, smoke detectors, and security sensor. This opens the door to practical, scalable smart home systems. So, about the conclusion. So, this IoT home automation project shows how smart systems can enhance comfort, safety, and efficiency in daily life. By combining sensors, microcontrollers, and cloud communication, we create we can create homes that are not only intelligent but also sustainable. So thank you, and I will be happy to answer any questions. So this is my contact details. Thank you for watching.